Well, hey guys, Mr. A here, and today I'm going to go through the steps with you on how to multiply polynomials together of various sizes. What I mean by sizes is the differences of number of terms. Okay, so as you can see here, just to warm us up here a little bit, I have a monomial times a trinomial problem here. And you guys should probably be able to quickly figure out how we would multiply these together. I'm going to give you a second. I'm going to pause for a minute and give you guys a chance to think about it, maybe even try a couple of things. And so pause the video and try a couple of things. And when you're finished, unpause and we'll go through it together. Okay, so for a problem like this, we're going to use the distributive property. In fact, we're going to use variations of the distributive property all throughout our multiplying lesson here, okay? And I say variations because we do have to do some different things regarding how many terms we're multiplying together here. So for a quick review here of maybe how we would do this problem, I'll just put it down here. And then I will distribute the 5x to every term inside the grouping. So I'll do 5x to 4x squared, and that'll become 20x to the third power. Because remember, there's a first power here. And when you multiply bases together, you add the exponents. Okay, next, I'll do the same thing here. I'll do 5x times negative 3x. I'll get negative 15x squared. And then finally, I'll do 5x times 8, and I'll get positive 40x. And there's my final answer. Okay, so all we have to do today is just distribute to terms, make sure that all the terms get multiplied by each other. So what we're going to do now is we're going to switch gears a little bit. We're going to take a look at how to multiply a binomial by a binomial. So two terms by two terms, okay? And so we're going to look at the one x plus 3 times x plus 4. So again, I'm going to pause for a minute and give you guys a chance to experiment with that for a minute or two, and then we will proceed from there. Okay, so on this particular problem, this is a very, very important kind of problem because there's a lot of other algebra problems of this type that you're going to encounter in your career. So we need to really focus on how these get multiplied together and do it correctly. The big thing here is make sure that every term in one polynomial gets multiplied by every term of the second polynomial. And the way we're going to do that is we're going to distribute every term in polynomial 1 to every term in polynomial 2. Now, when this process is only composed of binomials, which means both of the polynomials are just binomials, there is a special acronym we can use to make sure we have all the multiplication steps accounted for. And it is called the FOIL method. Okay? And I'm going to outline with you here how to do the FOIL method on this polynomial. Okay, so the letters in the word FOIL here represent different products that we're going to have to multiply together between the terms of the two binomials. The first letter F stands for first terms. So, okay, so we're going to take x times x. And when I multiply x times x, I get x squared. Now, for the O letter, that stands for the outer terms, okay? So I will multiply x from polynomial 1 times 3 from polynomial number 2. Okay, and I would get 3x. And I'll just put that here in parentheses too so we can follow along. I'll go back up here and do the same thing with the first terms. There we go. Now, for the I terms, that stands for the inner terms. Okay? And for us, that means 4 times x. So that becomes 4x. And last but not least, we have the last terms. Okay? For us, that becomes 4 times 3, which is 12. All right, and those are our 4 products. Now, to get the final answer, all we have to do is combine any products that become like terms. And for our purposes, I see 2. I see the 3x and the 4x right there. So what we're going to do is we're going to write all these products out over here on the side. Okay, so we're going to do x squared, and I'm going to actually just duplicate these. 3x, 4x, and 12. And we'll do x squared plus 3x plus 4x plus 12. So what we will do is we will have combine like terms. We can combine the 3x here together with the 4x. And 3x plus 4x is 7x. So the final answer becomes x squared plus 7x plus 12. And that's how we multiply 2 binomials together. Okay? So now we're going to try just a couple of examples with how to use the FOIL method so we're more comfortable with that. So here's our first one. I'm going to do this one, and then I have a couple other examples that I will leave you to do also, so for some extra practice, okay? So all we're going to do is we're just going to do the FOIL method, or another way to say it is to double distribute, which just means to make sure that you distribute both terms in polynomial 1 to both terms in polynomial 2, all right? So for this problem right here, we're going to start with 5x times 2x. All right, that's my F step. And that product is 10x squared. I'll move that down one line here. A little bit. And then we're going to do 5x times negative 1. Okay, that's my O step. I get negative 5x. I'm going to then do 3 times 2x for the inner terms. Okay, and I get plus 6x. And then lastly, I'm going to do the last terms, which becomes 3 times negative 1, which is negative 3. Now I'm going to combine my like terms here. And sometimes there might not be like terms. You just have to see what your products are at the end, and if there aren't any like terms, then you just have your final answer already. So those combine, negative 5 plus 6 becomes 1. So my final answer is 10x squared plus x minus 3. Okay, there's example 1. All right, now I'm going to let you try example 2 on your own. And then I will pause for a second, let you try it on your own, and then I'll show you the answer on the other side. Okay, so 4x squared times x is our first multiplication step. So it becomes 4x to the third power. Okay, then I do 4x squared times negative 2. I get negative 8x squared. Then I'm going to do negative 7 times x. I get negative 7x. And then finally, I'm going to do negative 7 times negative 2. And it becomes positive 14. Now, you got to be very careful with this and make sure that you always follow the sign before the term when you multiply. All right? And since I don't have any like terms to combine, that's my final answer. So I get 4x to the third minus 8x squared minus 7x plus 14. And that's the final product. Now, this same idea also applies when we have other polynomials. For example, like a binomial times a trinomial. Okay? So we're going to do this problem together, and then I'm going to show you another one here that you're going to work on as a practice problem. So on this problem here, all we're going to do is we're going to distribute the x to every term inside the trinomial, and then the negative 3 to every term of the trinomial. Okay? So we're going to start with x times x squared, get that product first. That becomes x to the third power. Then we're going to do x times negative 4x. That becomes negative 4x squared. Then we're going to do x times 4. And we get positive 4x. So those are the first three products. Now we're going to continue here. We're going to do this negative 3 distribution. So negative 3 times x squared, we get negative 3x squared. Negative 3 times negative 4x becomes positive 12x. And then finally, negative 3 times positive 4 is negative 12. Those are the 6 products. All right, so now we're going to find like terms and combine them. So I see that we have a negative 4x squared, and we have a negative 3x squared, so we need to combine those. And I also see that we have a positive 4x and a positive 12x, and we need to combine those. All right, so then my final answer is going to be x to the third minus 7x squared plus 16x minus 12. That's the final product. All right, I'm going to show you the next example here, number 4. I want you guys to try this one on your own, okay? I'll pause. Okay, so we're going to do 2x times 3x squared. For the first multiplication, it becomes 6x to the third. We have 2x times negative 6x for negative 12x squared. Okay, then we have 2x times 4 for 8x for the third one. Then we're going to do 5 times 3x for 15x squared. We're going to do 5 times negative 6x for negative 30x. And finally, we'll do 5 times 4 for positive 20. Make sure you have all 6 products, and then combine like terms. So those get combined. The negative 12x squared, 15x squared gets combined. And again, I see an 8x and a negative 30x. So when you combine these together, you should get 6x to the third. Negative 12 plus 15 is positive 3, so 3x squared. 8 minus 30 is negative 22, so negative 22x, and then plus 20. Final product. Okay, now that is the gist of multiplying polynomials. We just distribute every term in the first polynomial and make sure we multiply by every term in the second polynomial. Now, there are a couple of special cases that pop up from time to time. I'm just going to go over these rather quickly So you just see what these results are like so you know what to expect. But we're not going to spend a lot of time on these because it's not privy to having to know how to multiply them, okay? So we're going to go ahead and skip here a little bit. And we're going to go right here to this problem right here, number 1, okay? And then we're going to do problem number 2 together also. I'm going to show you which each one of these is. Now, when you have a quantity squared, like in problem number 1, you have to remember that this is x minus 11 times x minus 11, okay? A lot of students will just try to get away with saying that this is just x squared, either plus 121 or minus 121. But the problem with that is that that's not correct, because when you are squaring a binomial, you can multiply the binomial by itself. So the binomial by itself, like over here that I'm showing you with the arrow, okay? That means it's a FOIL method problem. It's going to have 4 products, not 2 products. So this answer is not going to work. Okay, you'll have missing terms. So let's go ahead and multiply it together now. You should know how to do that. So we'll do it real fast here, okay? X times x is x squared, okay? X times negative 11 is negative 11x. Okay, right here we have another negative 11x, and then we have a positive 121. So the final answer would be x squared. I have like terms here and here, okay? So it becomes x squared minus 22x plus 121, okay? This is an example of a perfect square trinomial. And the reason why it's called a perfect square trinomial is because the first and the last terms are perfect square numbers, okay? Those are both perfect squares. X times x is x squared. 121 is 11 times 11. Now, the middle term is twice the product of the 2 factors, okay, x and negative 11. If you take x times negative 11, that's negative 11x, and then you multiply that by 2, you get negative 22x. So here's the idea with this one. I'm going to go back up here for a minute so you can see this, okay, on this square up here, okay? If you multiply the sides together here on this square, you would get a squared, okay, and then a times b, and then another a times b, and then you get a b squared. When you add this together, you would get a squared plus 2ab plus b squared. Okay, now I'm going to put a minus sign underneath this first plus sign here, because if these terms, if b is negative in the binomial, then that becomes a negative sum, not a positive sum there, okay, or a negative term. But this is the general format for a perfect square trinomial, okay? Now, looking at the next example here, we're just going to go ahead and multiply this one out altogether also. I'm going to let you do that on your own, okay? I'll pause for a second. Okay, so we have 4x times 4x, that becomes 16x squared. We have 4x times negative 1, that's negative 4x. 1 times 4x is positive 4x, and then 1 times negative 1 is negative 1. This term combines with the positive 4x, but this time those terms cancel out because they're opposite signs, so those become 0. My final product is 16x squared minus 1. This is called a difference of 2 squares. Both terms are perfect squares. 16x squared is 4x times 4x. Negative 1 is 1 times 1. It's a difference of 2 squares. So back up here in my square picture, on B up here, I can do the same thing here. I'd have a squared plus a times b minus a times b minus b squared. Okay, the AB terms cancel out. I'm left with a squared minus b squared. So these are the general formats for these special cases. we're not going to worry about this so much in this topic, but we are going to worry about it a little bit more in the next topic, okay? When we go to do the reverse of some of these procedures. And that is where I'm going to leave things for this lesson. So all we have to do when you multiply polynomials together is to make sure that every term of the first polynomial gets multiplied by every term of the second polynomial. When you have binomials, both of them are binomials, you can use the FOIL method to multiply those together, otherwise known as double distribute. But in any case, it's just an extension of using the distributive property that you've learned now for quite a while. So if you have any questions for me at any point in time, just send me an email, and otherwise there should be enough information to get your assignment ready to go for the next day. Hope to see everybody soon. Take care. Bye-bye.